Hello again. Here we'd like to talk about space diagrams and free body diagrams. So, quick heading here, let me underline that for you. So, what do we know about these types of diagrams? Well, a free body diagram, we can call it an FBD, and that is used to isolate, I think is probably the best word to use, isolate a body from its surroundings. So, the body could be um, some ladders, box, a car, a train, anything. So we can isolate a body from its surroundings. Therefore, we can show the forces acting on it. Okay, so you haven't completely removed the effects of the surroundings, but if the surroundings are contributing forces, then we're going to be able to show those forces acting on the body. Okay, let's think of a box on a ramp. Now, here, I'm just going to draw a space diagram, which is essentially an observation of what you see, like a two, possibly even a 3D sketch. Okay, so we've got a box on a ramp, possibly in a factory. There could be a box full of Mars bars, which has recently been filled, or wherever it might be. But perhaps we could use something heavier. A box full of machine tools, say. Okay, so let me draw a ramp here. Perhaps I can use a different color. Okay, so perhaps there's been a conveyor over here, and the conveyor is sending boxes from right to left. This box I can draw in another color, perhaps. It's here, like so. Maybe the weight of the box is 2 tons. Don't forget, weight is a force. Okay, and therefore that 2 tons, well, effectively the box is traveling in that direction, but the weight of the 2 tons, of course, due to gravity, is always vertical from top to bottom. Let me just fill in a little bit more here for you to make this scenario a bit more complete. So 45 degrees here. This is just going to be the ground, which I just shade in like this. Okay, so the box travels that way. So effectively what we have here is a space diagram. Okay, so that's what's happening in 2 or 3D space. Now then, why don't we just isolate the box? We've drawn the box in pink here, so I'm going to go over to the right, make it a little bit larger, shall I? Okay, slightly larger, just so I can get all the bits in that I need to get in. We're going to have some force acting on the box down, and obviously that's gravitational force. So mass times acceleration due to gravity on the Earth, and the product of those is going to give us, well, whatever the force may be. So it's a 2-ton force. Okay. We also seem to have some force acting this way, and you guessed it, it's friction. Okay, so we have a force of friction, F, subscript small f. Okay, obviously here on the left we have some force acted on by, if the conveyor wasn't there, then the box is going to fall into the yellow zone here. So therefore the conveyor, the top of the conveyor, exerts a force on the box in the opposite direction. So perhaps I could draw that in another colour, maybe choose orange, like so. Okay, some force N acting in that direction. So we're not too bothered about specifics and numbers at this point. I just want to explain to you what a space diagram is and what a free body diagram is. Okay, so a free body diagram. And it's very useful because it takes away all the complications that we have over here for all the surroundings. And we just have this simple scenario where it's a bit easier for us to analyze. Okay, let me just elaborate finally a little bit more for you. Let's do a free body diagram, an example FBD, an example free body diagram. Okay, maybe we could think of, to go to white, a beam like so. Okay, so I have a beam. Maybe I could write in a beam here. Maybe a wooden beam, a metal beam, wherever it might be. This thing could be on supports. Okay, so it's supported at either end, like so. We have, essentially, we would have some forces acting there. So I'm going to do the actual free body diagram in white. So we'd have here a, oops, we change color to white. We have here a reactive force caused by this thing here. Okay, and it's on the left, so we call it the reactive force on the left. So that's the force holding the left side up, if you like. We could possibly have some force acting down here, some load on the beam there, perhaps another load on the beam over here. So force 1, force 2. We could have some sort of reactive force on the right. So R subscript R. So the bit in white there, as you can see, is going to be a free body diagram. Perhaps I could even rub that bit out for you. Okay. Obviously, the beams do not float in space. Well, they do in outer space, but in our space they don't. But we're showing that it's being held up by these reactive forces here on the left. This one and this one. Okay, and these things are acting downwards. So again, here's a free body diagram example for you. Okay, hopefully that's been useful. Thanks for watching and see you in the next video.